Welcome back. My name is Adam Soroka, MD of Cavendish Group. We are nearing the end of the Future Energy Systems event, which has been an extremely engaging conversation, I think, over the last couple of days. We're now on to our final panel of the conference, which is probably one of the, let's say, the most, I'll say important areas, but it's a critical area because it covers three parts of what a utility needs to achieve, I think, going forward. We've got some real experts on this one, talking about electrification, decarbonisation, and also digitalisation. And the actual focus is how will these three pillars be the future of critical infrastructure. So it's moderated by the wonderful Bradley Williams, VP of Industry and Innovation Engineering for Oracle Utilities. So I really thank Bradley for doing this all the way from the US. And over to you, Bradley.
Thank you, Adam. It's a pleasure to be with you all today, and glad to be sharing some thoughts with such a esteemed panel here, experts, to help walk us through this critical issue of electrification, decarbonization, and digitalization. My background is actually in the electric utility business. Spent 20 years on the transmission and distribution planning and innovation, and now with Oracle helping to drive those solutions. And such a excellent and timely topic of being able to support electrification and digitalization of the networks and the customers to be active participants of the network in order to provide a sustainable energy future for all. And so with that, I want to introduce our panel today. And like I said, we've got an excellent group of experts in this area, and we'll share some of their insights. And I'm going to introduce each of them. They're going to provide a little more background and provide some initial thoughts on this topic. And we'll just go around and start with these introductions. So Grant Elder is going to kick us off. He's the head of the IDNO, Optimal Power Networks at SSE. So Grant, give us a little more background with yourself and insights into this topic.
Thanks, Bradley. Yeah, it's really good to be here. Really exciting panel to be on. So yeah, as you say, I am head of Optimal Power Networks. We're an independent distribution network operator, part of SSE, and sitting in their distributed energy business. So that looks at whole system solutions, serving largely industrial and commercial customers. But right across, so I do the electricity distribution part. There's other parts of the business that do EV charging. We also have smart systems and digital services all in that. My background, I've spent around about the last 12 years in SSE, always in that kind of predecessor of the distributed energy business. Back when it was an IGT started off as. So we have moved through the industry a little bit. We are working with customers who are on a decarbonisation journey. They're on the at various stages. Some of them know what they want. They want behind the meter solar and storage. They want EV charging, and some of them just want as simple infrastructure as they can get. So we're looking right across the industry at how can we support that, and how can we help people on those journeys.
Excellent. Thanks, Grant. Next, Randolph Brazier is Director of Innovation and Electricity Systems at ENA, the Energy Networks Associations. Randolph, give us your background and some insights.
Yeah, thanks a lot, Brad. It's really good to be here. I can assure you that we're not all wearing the same shirt, so don't worry too much about that. But yeah, really excited to be here on this panel. As I'm Randolph, I work for a company called the Association.
Okay, so I think we're having a little bit of audio issues. We'll move on and come back to you, Randolph. Layla Sawyer as Secretary General of Current. And Layla, can you go introduce yourself and background on this topic?
Hello. Yes, thank you. Hopefully, you can hear me well. No
Yes.
audio issues. So Current, we are a European business association focused on innovative grid technologies. So basically all technologies that can both enhance the use of the existing grid, so make sure that we can actually transfer more energy through the grid, as well as maximize the efficiency of new grids. So some of our technologies are, for example, dynamic line rating, including very advanced sensor-based dynamic line rating, which can enormously help increase the capacity of the existing lines. We also have modular power flow control system companies, which can optimize the route that electricity is transported through. So if one line is congested, that it could take a parallel route, to put it simply. Also superconducting technologies, basically all kinds of technologies that can help us make the most efficient use of the grids possible.
Thanks, Layla. Let's go back to Randolph. I think you're connected. Go ahead, Randolph.
Hi. Yeah, hopefully you can hear me now, and apologies for that. I'm not sure what happened there. So as I said, I'm Randolph. Work for the Energy Networks Association. We represent all the gas and electricity networks in the UK and Ireland. And that includes networks both at transmission level, so high voltage level, and also distribution level or low voltage. And from an energy networks perspective, we think that we're pretty central and critical to achieving net zero, as we're going to be providing the underlying infrastructure, the cables and substations that are going to support these new markets and also enable mass decentralization of decarbonized technologies. However, to do this, the grid ultimately needs to be smart, it needs to be digitalized, and we need to ensure that it's done in a consistent and standardized manner across the country. And that's why at ENA, we're running a project that we call the Open Networks Project. It's effectively the strategy for rolling out the smart grid across the country. And we've started delivering a range of different aspects of that, but probably one of the most exciting and one of the most interesting areas that hopefully we can discuss later today is local flexibility markets. These local flexibility markets that we're running now are easily the largest in the world, and we've managed to achieve over 3 gigawatts being put out to tender last year alone. And what these markets are doing is not only is it reducing the cost of the grid and reducing the cost of enabling new capacity for the connection of these low carbon technologies, but it's also providing new revenue streams for people who have flexible resources and can provide services into that market. So there's a lot happening, and I'm really looking forward to the panel.
Thanks, Randolph. Next, we have Shira Lappin, who's Innovation Project Lead at UK Power Networks. Shira, go ahead.
Hiya, thanks, and thanks for having me today. So yeah, I'm Shira Lappin. I'm the Innovation Project Lead at UK Power Networks. We are the distribution network operator for London, the South East, and the East of England, serving around 8 million homes and businesses. Within our innovation team at UKPN, within UKPN as a whole, we are, adamant and dedicated to achieving net zero, and we see our role as critical to achieving that, as Randolph was just saying. And we use our innovation team to help achieve that as quick as we can, as efficiently as we can, and at the lowest cost to our customers. So we do a lot of work around the electrification of transport and heat, and how smart energy services can complement that and accelerate that transition, and also making sure that all customers and all citizens are involved in that transition.
Thank you. And last but not least, Carolyn Bragg is Director of Policy and Research, the Association of Decentralized Energy. Carolyn, go ahead.
Hello, good afternoon, everyone, and thank you very much for having me. So, the association is a trade association representing a number of sectors in the energy space, and particularly those who are decentralized and close to users, including demand-side response, so independent aggregators, suppliers who are building businesses for flexibility, heat decarbonisation, and energy efficiency. I guess with respect to my role and my perspective as we come into this panel, I think it would probably be difficult at this point to find a part of either markets or regulation for our energy system that is not currently under reform. There is huge amounts going on when you look, whether it's the electricity markets that govern how we are going to go from the current situation to a decarbonised, very flexible electricity system, all the way to how we regulate the networks, their role in providing markets and broader system planning, all the way through to some of the broader regulation and subsidy schemes. So whilst it's quite a challenging period at the minute for various reasons, it's also really exciting when you look to the longer term.
Excellent. So we're going to jump into our panel questions and discussion. So in fact, Carolyn, maybe you can kick this off when we start with how can we create a decarbonized economy with electrification, and in particular the significance of a decentralized and smart power grid. So Carolyn, what are your thoughts on how do we deal with that?
Sure. Well, I thought perhaps it might be nice to give a little bit of context, I think, in terms of just the pure scale that we're talking about and the emergence of smart grids in the UK. So if you look, for example, at sources like the future energy scenarios from the ESO, we're talking about tens of gigawatts of EV charge points, industrial and commercial DSR, thermal storage, and other forms of residential demand-side response, for example, using heat pumps flexibly, that will be providing overall the capacity and the flexibility that we need for the system going forward. Those tens of gigawatts, if you think about it, are we can kind of put them in contrast, for example, to the 3.2 gigawatts of nuclear that we're building in Hinkley, or around the kind of couple of gigawatts that we might see in terms of flexibility in, say, the capacity market right now. So it is an order of magnitude above what we have currently seen, and I think an extremely exciting opportunity when you look at the broader economic changes that will bring about. I think the other thing that I wanted to mention as well on the heat decarbonisation side, because it's a really important part in terms of how these things are going to work together. Obviously, everyone is aware, I imagine, of the 600,000 heat pump target that the government has to 2028, which obviously is another step up from the 30,000 annual installation rate we're currently running at. But beyond that, I think from our side as well, what we are quite focused on is the vast expansion in new heat network infrastructure that we are going to need to see in order to do this cost effectively. If you look at the government targets, we're looking at about 20% of heat demand being met by heat networks by 2050 to have an overall cost-effective system, which is probably about 95 terawatt hours, is what BEIS estimates, given what that 2050 system might look like, most of which is going to be electrified. It's going to be water source heat pumps, air source heat pumps, ground source heat pumps in loads of towns and cities across the UK, which is again an enormous change from where we have been before, and raises these incredibly exciting opportunities, I think, in terms of the way in which we use waste heat, which we are currently not making use of at all, whether that's wastewater, for example, rivers, canals, even our industrial offtake and energy from waste, where that heat doesn't really have a value currently. So I think to start with, I just wanted to raise just the sheer scale we are talking about at this decentralized energy level.
Yeah, thanks, Caroline. I wonder if there's some other thoughts, and let me just kind of kick off this conversation a little bit. An end-use customer buys an EV, puts in a Type 2 charger, and also replaces their natural gas heating with a heat pump, and they have way more than doubled their peak demand. And of course, the neighbor thinks that's pretty cool, so does the same. And now the whole neighborhood is under constraint. How do we deal with that? That becomes a key issue for reliability and effectiveness. So I think that's a key part of how do we manage that and provide those flexible programs to deal with this increasing issue of peak demand with existing networks. Wondered if there's some other thoughts that anybody has on dealing with that. Yeah, Randolph.
Yeah, so you raise a good point, Brad. I think from a network's perspective, you're right that if everyone on the street starts getting a heat pump and electric vehicle, we're gonna get congestion on the street. And in the UK, our sort of design factor, including diversity, that we use for distribution grids is typically in the range of 1 to 2 kilowatts per household. That's what we assume on average is being used. You're obviously putting in possibly a 7 kilowatt heat pump, a 7 kilowatt EV charge point, a heat pump that could be anywhere between 2 and 10 kilowatts. You can see the challenge there. However, we want to keep the cost down of enabling that capacity on the grid. So we could use the traditional solution of just building more networks, and in some circumstances that would make sense. But we also want to see what flexible technologies people have to help us reduce the cost of getting that additional capacity onto the grid. So that's why we have set up these local flexibility markers. We basically say on a postcode by postcode level, look, we can see congestion coming in this area. Who can provide this flexibility to us to relieve that congestion? And if you can provide it to us at a lower cost than the traditional grid solution, we will basically pay you to do that. And that sort of new way of thinking and those sorts of new markets are what's going to be absolutely critical to enabling all these new technologies to connect, enable the capacity on the grid at the lowest cost to our customers. But it also, as well as lowering the cost of the network, it also provides new revenue streams for people as well. So it helps those technologies that are flexible become more bankable.
Yeah, excellent. So I do want to move along, and I'd like actually Grant to answer this next question of how do we manage the risk of innovation and digitalization and scale, and focusing on electricity prices and the cost of electrical supplies. How do we deal with that based on this rapidly changing technology that customers are adopting and grids are leveraging?
I think it's really interesting. It follows on really well from what Randolph was just saying there, actually, that we talk about electrification as being the key to decarbonisation, and we talk about customers needing to be able to adopt low carbon technologies. But we also need the digitalisation needs to be there to give us that data. That data that tells us that this grid's going to be congested, or the digitalization to manage the usage on there. And obviously, we want this to be a positive discussion. Let's look positively to the future. But you asked a little bit about risk, so it can't be a purely unalloyed positive. And I think we've had up till now a very risk-averse approach to investment in across the energy industry. People are looking for 40, 50, 60-year returns. But now we're looking at digital technology, which is kind of changing by the second. There's new technology, new types of and new ways of using that technology, and new ways of abusing that technology, which we need to be aware of. So I think one thing that we need to make sure, if we are going to be able to benefit from the the cost reductions that allow decarbonisation to permeate right across, we need to be aware that it probably takes a different mindset and a different skill set within the electricity industry. And we are, we're the next hire into our business. We've got a graduate joining us after the summer, and it's not an electrical engineer for once. It's a data scientist, and that's someone who can help us understand better the technology and the availability of that technology. What could we be using to help manage networks? What the lifetime cost of that is, because if it's something that needs upgrading every 2, 3, 4 years, that's not the same as a fit and forget for 60 years. And what are the cyber security risks? What are the data security risks around that? So these are all things which, if you go back, I don't know, probably as little as 5 years, those questions weren't being asked in the energy industry, and now they are absolutely fundamental to doing what we're doing and being able to achieve this.
Yeah, it's great. It's a great point, Grant. And so I'm concerned also about those that can't afford to buy the electric vehicle or the heat pumps. The impact on them on a cost perspective with the infrastructure requirements to be able to support that, and the systems putting that cost on the non-participants. How do we make this fair for all? And I know we'll probably be getting into that in some of the other questions we'll be asking. But that's something else we need to consider is fair affordability for all, even if they can't participate with a EV, for example. So something else to consider. Anybody else have any other thoughts on this topic before we move on? Okay, if not, let's move on. I'm going to ask Shira to jump in on the next question. Is how do we support social responsibility and sustainability? It's kind of along the lines of this question. Achieving carbon neutrality while dealing with demand and renewable intermittency. So certainly the security as well as the social responsibility towards decarbonization and carbon sustainability. Shira, go ahead.
Yeah, I think that segues perfectly from the comment you were just making. I think it's key. It's key for a number of reasons. So I think, first of all, if you are to reach net zero and to decarbonize the grid, you can't achieve that if only some people can afford it and only some people can participate. By definition, that's not going to reach net zero. You need everyone to be involved. So there is kind of that practical reason for ensuring the kind of just transition and no one being left behind, as well as a fairness point, like you were just saying, that there will be reinforcement, and a lot of reinforcement will be socialized, meaning that people are paying for it potentially before they are partaking in it. And I think this is something that we're very conscious of, and we're very keen to be a responsible corporate citizen, essentially, and to make sure that we aren't leaving anyone behind. We've done a bunch of work in the area. For example, I think a key one is if you're thinking about EV charging and smart charging, and there's currently a new mandate that all at home and at work sort of private EV charging will now be smart charging first in the UK, and that will be the default. But that doesn't apply to public charging, because obviously public charging is a slightly different context. But there are many people who their at-home charging will be public charging, so they will be charging on street at home. So we want to see how can they take part in some of the flexibility products that we'll be offering, the smart charging, because that is a way. First of all, it helps us, it helps the grid, it then lowers costs in general for everyone, but it also will help customers. It will be a lower cost way of charging. So it's not fair that those who don't have access to off-street parking also don't have access to flexibility products. So we want to see how we can make progress in that area, and work with charge point operators and local government who are really key in that area to see how we can make that happen. And I think that applies to electrification of heat as well. I think heat is quite an interesting one because, you know, if you think about when you replace your heating system, it's usually kind of under duress, right? It's often your boiler breaks and you need a new heating system now. So you'll be looking for the most, and that could happen, and often does seem to happen at the worst possible time. And you will be looking for the most cost-effective option. So how can we get people to make the right decision, or the net zero aligned decision at that point, to go for a heat pump rather than another boiler, and sort of lock them out of electrification of heat for another decade? We need to figure out ways to make that a quick and easy and cheap way, essentially, of making that decision. So there's a lot of work that needs to be done, and I think we need to be talking to customers. You know, obviously there's a huge cost of living crisis at the moment, and cost is at the front of people's mind, which in some ways has sort of brought electrification to the fore. If you compare the cost of EV charging to filling up your car with petrol these days, it's looking better and better. But we need to engage with customers, see what their cost barriers are, how we can overcome that, and engage with actors who serve those customers more directly sometimes. So local governments, for example, who are looking at maybe district heat for council social housing, public charging for on street, and things like that, and kind of have a holistic whole system view of how we can make sure that everyone is taken along on the journey to net zero.
Yeah, excellent. I'm wondering if there's other comments or points of view that anybody would like. Yeah, Caroline, go ahead.
Yeah, I think there's also, I think, an interesting perspective perhaps to consider with this as well, is the sense of how far we recover subsidy schemes going forward onto bills, as well as where we think fixed charges will go on electricity bills. Obviously, as we've seen over the last, say, I don't know, 10, 15 years, there's been, for good reasons, for good policy design reasons, there's been a focus on recovering, say, the renewable obligation, the feed-in tariff, etc., the contracts for difference, from electricity bills. And obviously we're having a conversation about that and the difference that makes in terms of incentivizing heat pumps. But fundamentally, obviously, there is also the point that is quite profoundly regressive. As a way of doing things, whereas, for example, a decision to put that onto general taxation could be perhaps slightly more progressive, but has not been feasible or achievable politically in the UK currently. I think also when you look at it in terms of the really quite extensive network infrastructure expansion that we're going to see both on the electricity networks as well as newer forms of infrastructure such as hydrogen, at the minute, that would also go straight on to energy bills. And I think there's a discussion to be had there as well about our longer term approach to this and what is the most progressive way to be approaching things.
Yeah, excellent. Any other thoughts on that before we move on? Okay, let's move on. So I'm going to ask Layla to follow up in the next question is what are the best practices for prioritizing optimization of assets, and in particular accelerating digital transformation and transparency? Layla, go ahead.
Yeah, so just what I've been hearing in this panel, in the journey to net zero, and sometimes I think it's good to consider just the scale of what needs to happen in the coming decades. So if we look now, so we work at a EU level. So if we look now at what are the plans for the EU, you know, for phasing out Russian fossil fuels, and already the Green Deal that was put in place before that, just how big a transformation our grids are going to need. And this is a quite big, these are quite big numbers to grasp. And so we do see that probably some new grids will be needed, but as we've already been discussing in this panel, we need to keep the overall costs as low as possible for all customers for all citizens. So if you then look at then what are the best practices, I think what's important is we need all the different solutions that are out there. So we've heard a lot already about about flexibility, smart charging, heat pumps, etc. We also need to look at in the grid what can be done and what are the best options for different situations. So we commissioned a study last year looking at how different solutions can complement each other. And what we saw is that all solutions individually, such as superconducting cables or dynamic line rating or modular power flow control systems, that they can all individually had a certain effect, but especially all together were greater than the sum of their parts, so to speak. So for example, altogether, these solutions could save in 2030, based on our scenario, 90% of redispatching costs and save 3 terawatts of renewable energy curtailment. So if we just look at what we are trying to achieve in the coming years, just that we will need to use all these different solutions. And then when we look at transparency, we need our network operators to also be transparent in what is working, what is not working. We see that in every country, network operators want to trial their own solutions, which of course makes sense. But some technologies have already been very well established in other countries, so we really need to learn from each other as well, and take the learnings from other countries and to help us to really speed up and do all of this much faster than we have been doing up until now. So I think I could go on about this, but I don't think I'll leave it there for now.
Yeah, let me jump in real quick, and then others can jump in as well, because I think it's a real opportunity for creating information, because of course the distribution operator has obligation for safety, reliability, cost effectiveness for the connected customers. And in order to do that, they kind of need to know what are they connecting to, and I think that becomes a challenge as the customer gets further away from them with different aggregators and different services that keep that. So I think as part of that digitalization is the information for the network operator of how best to optimize. So they need the information of what are those digital assets, what are those EV, and capturing that and sharing that in order to get the most cost-effective, reliable grids. And so having the concept of a portal, in the same way, healthcare has kind of gone that way, digitalizing information about healthcare, so health providers can provide more optimal services in the same way. So I wonder if there's some additional comments about being able to share that information, particularly like when we start getting into day-ahead markets, and being able to simulate what those impacts are going to be on a day-ahead basis. Is this too big? Is this too much of Big Brother trying to get into the business of an individual homeowner, or is this essential for critical operations? Randa, if you had your hand up, so go ahead.
Yeah, so I think from a network perspective, that information is critical. It means that we can design, build, and operate the networks in a much more efficient manner if we can actually see what's connected to it and where. Obviously, there needs to be sort of appropriate data restrictions around that in terms of personal data. But in terms of building the grid out, if we have that info, we can do it in a much more efficient manner. But I think on the flip side of that, us as networks also need to make our data available to people who want to connect and use the grid. Because if we make it available to them, then they can better locate their devices, they can better understand how the grid is operating, they can better understand where the opportunities are, for example, to provide flexibility services. So in the UK, all of the energy networks have signed up to the open data principle, or assumed open data, which is where basically we assume that the data from the energy networks is made available. We make it available to people unless there is a good reason not to. And that's something that we're trying to do by digitalizing all of our systems and then making that data open and available online and in machine readable formats and things like that, so that people can access it. But it also has additional benefits that we don't even know about. So by making that data available, people can innovate, they can use it to create apps and tools and services that we haven't even thought of. So the openness of data needs to come from both sides. It needs to come from the networks, and it also needs to come from the devices connecting to the networks.
Excellent. Yeah. Let's see who's next. Grant? Go ahead.
I was just going to say very quickly to follow up on Randall's point there that it does take time, and we have to appreciate that if we start monitoring now on what is actually quite a hot sunny day, we don't know then what the impact on the networks will be in the middle of winter, or what it will be through kind of next year, and how that changes. I think our network designs are based on millions of data points over decades, and we are going to have to run very, very quickly to do what we need to do with kind of data capture, data analysis. And that's why I think I agree that the more data we can get out there and kind of crowdsource the analysis of that, we will get more people coming in with different solutions and different ways to react to it.
We seem to have lost Bradley, but
we lost Bradley. Go on, Caroline.
Perhaps if I could
Sorry,
give
I
a
think I jumped in
further
before you anyway.
perspective. I think the other thing, though, I think that's useful to consider is I feel we're coming at this from a context where, especially at a sort of ESO, perhaps kind of national level, there have been relatively small numbers of generation and storage, I guess, in terms of pump storage, for example, that are being dispatched in response to the needs of the system. And so the information requirements, while still really quite substantial, it has been possible to use, I think, an architecture that's really very reliant on data coming into a central place, being kind of processed and looked at, and then decisions being made on that basis. I think the sheer scale that we're talking about in terms of how many more assets are going to be responding flexibly, and also what they are in terms of much more demand side response, I think means that you do have to take perhaps slightly a more radical view to how you build that kind of architecture and how you think information is going to flow through this system. I totally agree with the points made in terms of perhaps registering and a view of what assets are being installed where, but I think we do need further discussion about how, on an operation basis, this information is best moved around the system and acted upon.
Are you back, Bradley?
Sorry, I lost you guys for a minute. Sorry. Did we finish that up? Are we ready to move on to the next question?
I think so, yeah.
Can you hear me okay? Okay. Randolph, I think you get the last question before we open it up to other questions. So how can we support electrification and economies of scales, analyzing policies and changes required for accelerating large-scale electrification and the impact of the current electric system?
Yeah, thanks, Brad.
Go ahead.
So yeah, obviously trying to scale up this and trying to accelerate this rollout of electrification is going to be difficult because the underlying infrastructure wasn't designed for it. So I think there's a few things that we need, and I like odd numbers. So I've identified 5 things that I think would be really beneficial to scaling that up and accelerating it. It's not to say these are the only things, but I think these are 5 critical areas that we need to look at. So the first one is on capital costs of devices. So we need to lower the capital costs of these low carbon devices. If you think about in a home, an electric vehicle, a heat pump, a battery storage device, as well as all the work required in the home to support those devices, such as energy efficiency measures and retrofitting of those, they can be quite expensive. And they are typically more expensive than the existing devices that we use to provide those services. So we've got to bring those capital costs down. That's critical, and there's a range of ways that we could potentially do that. The second thing that I think we really need is, and we've touched on this already, is around new markets and appropriate market signals. For example, time of use tariffs. The reason we need these is because we need to better reflect, or more accurately reflect, I should say, the whole system cost of energy at any particular point in time or location. So we need to better represent the actual cost of using or consuming energy at any point in time. However, we also need to do that in a fair way that protects people who can't afford it, and we need to ensure it's equitable ultimately. The third thing I think we need is better customer propositions. I think at the moment, broadly speaking, people don't really care about energy. They don't really know about it. They don't really understand it. It's a pain for them. It's a bit of a burden. So we need to create propositions for customers that are really easy to use, really easy to understand. They don't really need to do too much. A lot of it is automated and it happens without them knowing. And it needs to be really user-friendly. The bits that they do interact with needs to be really user-friendly. No one is really going to be sitting there at home watching different energy markets and waiting to respond with their devices. That all needs to be automated. There might be some nerds like us who do it, but in general and on average, most people won't want to engage. So a lot of this needs to be automated and really simple. The fourth one is around digitalisation. I think we've already touched on this and how important digitalisation is to ensure more efficient decisions and optimization. So I won't touch on that. And then the last one is around infrastructure. We really need to invest more in infrastructure so that we can ensure there's enough capacity, both from a generation but also from a grid perspective, to enable the decarbonisation and connection of all of these devices at the lowest cost. However, this needs to be done in advance. It needs to be done with a 2050 mindset, and it needs to be done quickly. Infrastructure, it's big, it's bulky, it's possibly slow to build out. So we need to be able to speed this up, do it quickly, do it in a more agile manner. And as I think the Committee on Climate Change said, we need to build it once and build it right. So, take a 2050 view and do it once and do it properly.
Yeah, excellent. Discuss the role of standards in achieving some of this. I know there's a lot of emerging standards, like for smart inverters, 2030.5, other things, common model exchanges, a lot of activity in that space. I wondered if you can share additional thoughts on the role of standards in supporting that.
Yeah, I can kick off. I mean, standards are absolutely critical, and they're something that we advocate strongly all the time, not just within a country, but internationally, right? If you think about electric vehicles, if you think about heat pumps, a lot of these devices that we have in different countries are coming from the same factories, the same locations. So, ensuring that they integrate with the grid in a consistent and standardized manner will really reduce costs. It'll save us creating all these bespoke systems that don't work, but also it's really going to drive more investment into these technologies and into the energy system in general. So we think that standards are absolutely critical. And not only that, it's going to mean that people can easily interact with these devices regardless of where they are in the world.
Yeah, excellent point. And along those lines, I think even going down to building standards that require support for smart devices that have that communication standard capability, so can provide that interoperability like you've discussed. Any other thoughts from the panel on how we can support economies of scale for electrification?
Yeah, if I could jump in. So I agreed with basically everything that Randolph said, and obviously, we're working on the same kind of part of the system. But I think what's quite interesting is the interaction between, I think it was point 3 and 5. So being able to make the investment once and making it right. In order to do that, we need to know sort of how much we need to invest and where. And part of that is knowing kind of how much of kind of smart systems and smart grids we can rely on. And I think the automation point is really key for us to be able to rely on our forecasts and assumptions there, because if it is easy and automated for customers, then we can rely on it more that it's going to happen, and there is going to be that flexibility there, which means that perhaps we need to we can focus our reinforcement on areas where it's harder to have that flexibility, for example. I also think it's key from a sort of behavioral point of view, like Randolph was saying, it's boring essentially. And I remember kind of conversations like 5 years ago around open banking, when everyone thought, oh, you'll have one app which will then optimize your money and you'll be changing bank account every 3 days for whichever one it gives you the best return and whatnot. And it didn't, it does happen. It exists and it happens, but it hasn't really taken off. I think because, it's your money, people feel quite protective of that, and it feels quite exposing to do that. Whereas I think energy is a slightly different product. I, at least speaking personally, I would be more willing to sort of hand over that control. And if you said yes, as long as you can guarantee that the lights are on, the car is charged, the house is warm, do whatever you want, be my guest. And if there's always kind of an emergency override, if people are particularly dependent on certain devices, etc., then I think there is great opportunity for scale there. But we need to kind of get the products right to be able to rely on that and to know how much we can rely on.
Yeah, excellent. So yeah, go ahead, Caroline.
Oh, just one final thing, I think, just to add, if I may. I think the other part of this is which bits of the supply chain would come under pressure as you kind of start to get this ramping up. Because I think it's actually quite interesting when you get into some of the detail of this, and perhaps not entirely intuitive. What we see, for example, on the heat network side is, you might say, oh yes, what we're lacking obviously is kind of people who are installers, people on the ground doing the civils, for example, etc. But what we also see is that there's quite a lot of gaps, for example, in people in GB who have significant kind of senior expertise in doing very large program management for this scale of heat network infrastructure. It exists in other countries in Europe, but perhaps not so much in the UK. And that might be the same also for quite specialist skills, so things like legal. When you're putting together some of these commercial structures. And I think we see it as well. If you look, for example, at where the supply chain was just as we finished off the renewable heat incentive here in the UK, the pressure on, for example, those who were doing, for example, say boreholes for ground source heat pumps became quite acute. So areas like that where we really need to it is a platitude, but we really need to get a bit sorted on that, and potentially ahead of when we're really starting to see the ramp up in these installations.
Yeah, I'm wondering as we start to kind of wrap up this discussion, if we can also address the issues of cybersecurity, because now we have many devices, smart devices, digital devices that are interacting with critical power systems and markets, and is vulnerability for bad actors to disrupt that market is a real threat that needs to be dealt with, needs to be managed. So I'm wondering if if other panelists have some thoughts on how can we essentially validate that people that are participating in energy markets are valid users that have real devices, and that their bids or their participation is within the limits of their connected devices. Or is that is there validity to these participants, and how do we deal with that? Yeah, so Caroline, I think you had your hand up. Go ahead.
Yeah, I think just as I think the first thing to say is I think the standards that we're seeing, for example, coming forward, so PAS 1878, 1879, for example, which are currently voluntary but likely to become mandated going forward, look specifically at cybersecurity for smart domestic appliances, which I think is a really positive way forward. We're also expecting in the UK further proposals from government on particularly managing really quite a range of what they're calling kind of load controller sector, which might be also things like switching devices, other things like this, and what the cybersecurity implications of that are. I think where we see it is that one of the nubs I think that we are going to get to is the effectively the infrastructure that you are using to manage some of those risks. So there is a lot of discussion, for example, about the DCC currently as part of that discussion, but clearly that needs to be weighed up against, for example, the latency and some of the other concerns that we see with that, especially if you're wanting to access these more sophisticated services.
Excellent. Other thoughts?
Yeah, I had something on that. And it kind of ties back in as well to what Randolph was saying about standards. Cybersecurity is one of those things that is uppermost in our mind as network operators. When we are putting control units onto our networks that are remotely controllable, we need to make sure that they are absolutely 100% secure. Something we're seeing, and back to the question of cost, but also supply chain pressures at the moment. We've got long lead times for things like routers and things like Kelly switching units. We're now starting to see people proposing equipment that we've not come across before, and putting that through the kind of the checks to make sure that it is secure, that it is robust, that it is utterly cyber secure. That takes time. So making sure that we're not putting things onto our systems, onto our networks that have any gaps in them. That comes back again to standards, but it also has an impact on making sure that the costs are right, the benefits are right, because it sadly only takes one of these to go wrong potentially, and you've caused a catastrophic failure somewhere.
Yeah, excellent. Yep, Randolph.
Yeah, so I agree with what Caroline and Grant said, and networks spend a lot of time and money and resources thinking about cybersecurity. But one thing I would add is that we shouldn't use cybersecurity as an excuse not to progress. There are a lot of, there's risks obviously that we need to address with more entry points to the grid, but equally by decentralizing across our supply across a much wider range of resources, we also have security benefits in that we're not so reliant on individual pieces of plant and large centralized plants. So there's a lot of advantages as well to decentralization in terms of security of supply and reliability, etc. as well as the risks that we mentioned around cybersecurity.
Yeah, thanks, Randolph. I realised I'd taken things down a little bit there. So yeah.
Well, we're running out of time. I'm wondering if each of the panelists can just share some final closing thoughts, maybe some encouragement of how we go forward along these lines. So I'm going to start with Layla. I wonder if you can share some closing thoughts for us.
Yeah, so indeed, we've heard a lot of the different risks and solutions as well. But I think the most important thing is that we really need to make haste, let's say, because, yeah, well, as I said before, what we need to do in the coming decades is just enormous. And I think we need all the solutions that we can get.
Excellent. Shira. Any closing thoughts?
Yeah, I guess similar. You know, it's a bit trite, but necessity is the mother of invention. We don't have a choice. We have to electrify. We've got to reach net zero. But on top of that, it's exciting and it's interesting and it's an opportunity. We've heard a lot about different parts of that system and different ways to get there, and I think we just need to keep the conversation going and keep the action going, and yeah, don't sit on our hands for too long. We have to kind of get out there and try things and do things, get there as quick as we can.
Excellent. Caroline.
Yeah, I guess I would say two things briefly. I think the first thing is just quite how profound the transformation is that we are talking about. We're talking about the flipping of markets from dispatching generation against a background of demand to the opposite. We're talking about DNOs who used to be cable people to system service operators. And I think with that, I think given how fast we also need to go, there's a need perhaps to be more open to trying stuff, even if that means that where we ultimately get to is more expensive than the absolute optimum.
Thank you. Yeah, good. Grant, next. Go ahead.
Yeah, I mean, I'd agree with all of that. You know, we need speed. We need to go there. We need to get decarbonisation done, if I'm allowed to say that. But we'll get there by taking everybody on the journey. We need to get customer propositions right. We need to look at the whole system, and a genuine whole system solution from the end user and the devices that they have, right up the way to where the power is coming from.
Excellent. And Randolph.
Yeah, I think the guys have really nailed it. I think I'd summarize it by saying, how exciting is it? You know, all this change, all this transitioning, new technologies, new markets, everything's changing. It could be seen as daunting, but I'm pretty glass half full. I think it's super exciting. And if you're a young person, you should absolutely be looking at energy and going into the energy system, because it's definitely where all the cool activity's happening.
Yeah, excellent. And I echo that. I've been in this industry since the 1980s, and never in my career has there been the pace of change and the excitement of how we are solving some big issues in the world through this. And our industry is very safety minded by necessity, and we have always done things one way in the past. And my colleagues, when we start introducing these new ways, it's like, that's not the way we do it. We've done it this way. And I think a mind shift is essential. Is no longer say, well, we don't do it that way, or we can't do that. Is how can we do that? Is just opening up our perspective of, yes, safety, reliability, security is essential, but so how can we embrace this transition of the digital energy economy and do it safely. And it's going to require new ways of doing things, imagination. How do we engage customers? Customers are no longer loads or ratepayers. They are active participants of our energy ecosystem. So I think that's key to how we can move forward. And this has been really great engaging with everybody. I really appreciate these excellent insights and thoughts. With that, I'm going to turn it back over to Adam to close out our session.